Okay, this is going to be section 2.3, which deals with the product rule and the quotient rule. So the last section we dealt with finding the derivative of a function using some derivative rules. This next section is just expanding on that, and then the following section is also expanding on that. So this section is devoted to two new rules, and it's the product rule and the quotient rule. So I went ahead and wrote down the formulas. So what's boxed in blue is how the textbook writes it. And you're taking the derivative of f of x times g of x. And it turns into f prime of x times g of x plus f of x times g prime of x. Now my notation was boxed in green. It's just a rewritten version of what's boxed in blue. And instead of using f of x and g of x, I use the letters u and v. So u and v are functions. I'm using u in place of f of x, and I'm using the letter v in place of g of x. So it looks less messy when I write the formula down. So it's equal to u prime times v plus u v prime. Yeah, so I'm just basically, again, I'm using u for f of x and then v for g of x. The next formula is the quotient rule, and a quotient is just a fraction. And so first, the textbook notation, taking the derivative with respect to x of f of x divided by g of x, where you can't have g of x be 0 since you can't divide by 0. And it's going to equal to the following. On the numerator, it's g of x times f prime of x minus f of x times g prime of x divided by g of x squared. Now my notation, I use the letters t and v, and I like to think of it as t is for top function. And then the letter b for bottom function. And this is how I would write it. So the derivative with respect to x of t divided by b, it's going to be equal to the bottom function v times the derivative of the top function, then minus the top function times the derivative of the bottom function. And then that's all divided by the bottom function squared. So I'm just using different letters. In this case, instead of f of x, I'm using t. Instead of g of x, I'm using the letter b. And I like to think of them as top function and bottom function. All right, so these are the two rules for this section. Now we'll go into an example where I apply one of these two rules. But first, let's say I wanted to find the derivative of y equals 3x minus 2x squared in parentheses times 5 plus 4x. Now I will show how to use the product rule, but first I'll show that we can still find the derivative of this using the rules that we already know from the previous section. And the first thing we need to do is to rewrite the function into a format which we can find its derivative. In other words, we need to expand it or use distribution or FOIL. So what you see here is just me demonstrating the FOIL method or distribution and expanding it out. And what's in pink or purple is the result of the first, so like for FOIL, it's first, outside, inside, last. You have the first, and then the outside terms, inside terms, and the last terms. All right, so then and I rearranged it so that the variable or the term with the highest exponent is listed first. So I have the negative x cubed, I list that first, and then the 2x squared was the result of 12x squared minus 10x squared, and then I put the 15x last. That's just how we're used to writing these polynomials, is in descending order according to the exponents. All right, so now I can find the derivative using the rules that we already know. And finding that, that's what's happening here. So I factor out the negative 8 and then focused on taking the derivative of x cubed, and that's using the power rule. All right, so the power rule is what I'm writing down right now. All right, that's what I'm applying to the x cubed. And so you drop down the exponent, so I drop down to 3, and then times x, and then raise to the 3 minus 1. You subtract 1 from the exponent. And the same premise I'm applying to the x squared. But first I factored out the 2 and then focused on the x squared. So this time your exponent's 2, so it would be 2x to the 2 minus 1. And then for the last term, 15x, you factor out the 15, and then I focused on x, and the derivative of x is 1, because that's that special case of the power rule. All right, so these were rules discussed in the previous section that you're expected to know at this point. So from here, I just simplified it. Negative 8 times 3 is negative 24, and then x squared, and 2 times 2 is 4, so plus 4x, and then plus 15. So this would be the result, or the answer. All right, that's the derivative. Now, alternatively, we can use the product rule. So this is the original function, and I'll write down the product rule. And I'm going to do it using the notation that my notation versus the textbook, meaning I use from above. I'm going to use this one versus the other one. And it's just using the letters u and v versus f of x and g of x. All right, so the product rule says we take the derivative with respect to x as of u times v, and I'll use a different color. I'll use u for green, and then I'll put v in purple, just so we can get a feel for how to apply the formula. So it's equal to u prime times v, so that's the first part. You take the derivative of the first function times the second function is v, and then plus u times v prime. So u prime times v, derivative of the first function times v, plus the first function u times the derivative of the second function v. All right, that's the formula. Now I'm just using colors just to demonstrate how to apply it. And in this case, our u is the first function, 3x minus 2x squared. So that's what u is. And then the second part, 5 plus 4x is v. All right, so if you see in the formula, I have u prime and v prime. So I'm going to focus on each part and find its derivative. So u prime, taking the derivative of 3x minus 2x squared, that becomes, so I factor out the 3, derivative of x is just 1, so this is 3 times 1, then minus 2, take the derivative of x squared. Well, x squared becomes 2 times x according to the power rule. So u prime is 3 minus 4x. Now for v, taking the derivative of 5, that's 0 because that's a constant. So it'll be 0 plus 4 times the derivative of x, and the derivative of x is 1. So it'll be 0 plus 4 times 1. So v prime is 4. So I'm going to circle the things that we're going to use and plug it into the product rule formula. So using this formula, we have y prime is equal to u prime times v. Well, u prime is 3 minus 4x. So I'm going to first write that. All right, that's u prime times v, and v is 5 plus 4x. Then plus u times v prime. And u was 3x minus 2x squared. And then v prime is 4. Okay, so all this times 4. Now I'm going to focus on simplifying this. So again, this is u prime. This is v. And then u times v prime. Now, foiling out the first part, all right, we do 3 times 5 is 15, and then 3 times 4x is 12x. Then distribute negative 4 times 5, it's negative 20x. Negative 4x times 4x, that's going to make negative 16x squared. So that takes care of this part. Now for the other term, I distribute 4. So I do 4 times 3x is 12x. And then 4 times negative 2x squared is negative 8x squared. Then it's a matter of combining the like terms. And let's see, so I have negative 16x squared with negative 8x squared, that makes negative 24x squared. And then I have, so for the x's, I have 12x minus 20x plus 12x. So that's going to make 4x. And then last I have the 15. All right, and then that's going to be, should be the same as what we had before. Yeah, so it's the same answer. And honestly, for this, I probably would have done it the first way, using the ways that we already know, instead of using the product rule. It just seemed like it took less work. So the thing is, for this particular example, I probably would have used the first way we did the problem instead of using the product rule. So I would have used the rules from section 2.2 and FOIL instead of the product rule, just because it seemed to be less work. But there comes a time where you have to use the product rule. So for example, say I had the function y equals x times sine x. So I have this trig function conjoined with x, and I can't use the techniques that I learned from the previous section to find this. So I have a product, and I have to use a product rule for this, for finding its derivative. All right, and I'm not gonna keep changing colors like I did. That was just for sake of demonstration to color coordinate. That I use green for U and purple for V just to save time. I'm just gonna work it all the way out. And the product rule is the following. So it's U prime times V plus U V prime. And in this case, our U is X and our V is sine X. So the derivative of X is 1. So U prime is 1. The derivative of sine we know is cosine from the previous section. So V prime is cosine X. So that means I can go ahead and find the derivative. So be y prime equal to U prime times V. Well, U prime is 1. So it's 1 times V, which is sine X. Then plus U times V prime. Well, U is X. And then V prime is cosine X. So y prime equals sine X plus X times cosine X. All right, so hopefully that made sense now, how I'm applying the rule. Now the rest of this is just going over example after example, demonstrating the product rule and quotient rule. So I'll first go through some with the product rule and then some with the quotient rule. Now this was one where I had to use the product rule because of the sine X, whereas the previous example, I showed 2 ways to do it. And the first way was just using the techniques from the previous section. You just first had to FOIL it out. The other technique was using the product rule, which to me personally, I would have done it the first way. But for something like this, I have to use the product rule. So I'm going to pause the video and write down some examples that we're going to use or to find the derivative using the product rule.